Okay, welcome again to WSHS or Woodbridge Geometry Virtual Tutor. What we're doing today is working with polygons. So what we're going to do is apply the angle sum theorem for polygons and find the number of sides. So we're going to be looking at both interior, which is inside, and exterior, which is outside. And we're also going to be looking at different types of polygons, and these are all going to be regular polygons. And we're going to figure out, based on angles, how many sides do we have. So we can go backwards and forwards with that. The biggest thing that we're going to have to know in order to figure all this out is we need to be able to make triangles within our shapes, because the triangle is going to be the basis for determining what our degree measures are and what the number of sides are. So we can see how many triangles we can make inside each shape. So what you want to do is follow these rules. Okay, if I'm trying to make a triangle, you cannot draw lines that intersect like this. That doesn't make, we're not talking about these. There are not 4 triangles in a square. So you cannot do that. Nor can you overlap. So I can make a triangle like this, which means I have 2 triangles, 1, 2, but I can't go backwards again and say, oh no, I have 3, 4. I can't do that. So you can't overlap them either. You can't do this. This is disgusting. What you need to do is be able to draw a triangle from, or a line to separate, make a triangle from one vertex point to the other vertex point. You can just stop in the middle or stop wherever you feel like. Okay, so this is what I mean by making triangles in each shape. So what you want to do is take and find, with your diagonals, try to make triangles. So if this is a quadrilateral, I know a quadrilateral has 4 sides here. So I would go from one diagonal to the other diagonal, and that's it. I have 2 triangles here, right? This is a pentagon. A pentagon has 5 sides. So here, if I started with this vertex point, I can go from this point to this diagonal to make one, from here to here to make another one. I can't do anything else more than that. So I have 1, 2, 3 triangles. In a hexagon, I have 6 sides, right? I can start at any vertex point I want, but I've got to go to the other vertex point. If I went here, I haven't really done anything different. I didn't make a triangle, it just went over that line, right? So that's why we can't do that. So we have 1, 2, 3 lines I can draw, which makes 1, 2, 3, 4 triangles there. In a heptagon, 7 sides. If I wanted to start at this vertex point, remember I can't go there, that's just overlapping what I've already have. And these were already drawn, that's why I'm drawing right over them, so I'm not like, contradicting myself here. I'm just showing you how these were drawn. So we have 1, 2, 3, 4, 5 triangles. That one. And an octagon has 8 sides. So we have 1, 2, 3, 4, 5 lines I can draw, which means I have 1, 2, 6 triangles. So that's how you would draw your triangles. So why in the world do we need to draw triangles? The reason is because we can find the degree measure by taking however many triangles we have and multiplying them by something. So we're going to figure that out, okay? So I want you to go ahead for a video and fill in the table with what we've got so far. After you're done, press play again and I'll work with you on filling the rest in. Okay, so here's my triangle, right? What we're going to do is determine the number of triangles in each shape and then what the sum of the angles would be. And we'll try to figure out what the rule is here, okay? So if I have a triangle, we know a triangle has 3 sides. And how many triangles do I have in a triangle? Well, I only have 1, right? 1 triangle in a triangle. So I can just make this a 1. There's 1 triangle there. And what do triangles and the angles of a triangle measure? Well, the total measures 180. You probably already know this from what you've learned early on. Okay, in a quadrilateral, quadrilateral has four sides. So how many triangles do I have in a quadrilateral? Well, we would go from one vertex point and go to the next diagonal. Remember, I can't go outside. I can't do this because I'm just overlapping there, right? So I got to go from one diagonal to another, or one vertex point to another vertex point without overlapping. So I have two triangles. And we know that the quadrilateral adds up to 360 because you've already done this before. So if I know that, I would take 2 times 180 in order to get 360 because I have two triangles and each triangle measures 180 degrees, right? So that's why we have 360 in a quadrilateral. If I can make two triangles, 180 and 180 give me 360. Pentagon has 5 sides. We said a pentagon can make 3 triangles. So we would take 3 times 180 and we would get 540. A hexagon has, wrong way. Hexagon has 6 sides. And we said if I started here, how many triangles can I make? 1, 2, 3, 4. 4 times 180 would give me what? So go ahead and pause the video and see if you can fill in the rest of the table with the degrees, the number of triangles for this one, and all the degrees for these. Unpause it, see if you got it right. Okay, so what you should have gotten here was 720. This would have made 5 triangles, and that would have been 900. This would have made 6 triangles, and that would have been 1080, right? So for your heptagon, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And for your octagon, 1, 2, 3, 4, 5, 6. Okay, you can go ahead and pause this as well and fill in for the nonagon, decagon, and dodecagon. These are 9, 10, and 12 sides. So they have 7, 8, and 10 triangles, and these are their degree measures here, 1230 and 1800. When you're done, you go ahead and play the video, and then we're going to talk about an n-gon. Okay, so an n-gon is a shape with n sides. So n stands for the number of sides in a polygon, okay? Regular polygon. So if I say, if it's like 25 sides, what would be the name for that? Well, it's highly unlikely. But we would just call it an n-gon for the ones we don't know how many sides there are, okay? So for an n-gon, what we're doing is looking for the rule here, okay? So the number of sides that an n-gon has, we don't know, so we're going to label it. For the number of triangles, how would I figure out the number of triangles in an n-gon if I don't know how many sides it has? Well, what were we doing? What was the pattern that you noticed with the previous ones? 3 sides had 1 triangle. 4 sides had 2 triangles. 5 sides had 3 triangles. 6 sides had 4. 7 had 5. 8 had 6. So what's going on here? Do you notice the difference? Literally the difference, meaning subtraction, right? So however many sides we have, we would take that number and subtract it by 2 in order to figure out the triangles. And then remember what we were doing was we took whatever that number is and we multiplied it by what to get the degree. Remember we said everything was multiplied by 180, right? So we do 180 times however many triangles we have in an n-gon, and that would give me my total degree measure. So you want to go ahead and make sure you highlight this, because this is the rule. That applies for every regular polygon there, or every polygon there, I should say. Okay, so now let's talk about interior angle sum theorem. So if a polygon has n sides and S is the sum of its interior angles, this is the rule we were just talking about, 180 times n minus 2. The exterior angle sum theorem means that all of the exterior angles in any shape would add up to equal 360. Because the more and more sides you get, if you notice, the more and more sides you have, the more and more it starts to look like what shape? What shape does this almost look like? It almost looks like a circle, right? So the more and more sides you have, the closer and closer you get to 360. So anytime you add up the outside angles there, they're going to equal 360. All right, so we're going to try some examples. Find the interior angle sum of each polygon. So what we need to do is figure out, we know the rule, right? 180 times the number of sides we have. So let's figure out first how many sides we have here. 1, 2, 3, 4, 5, 6, 7. So the number of sides we have is 7. How many triangles do we have? Well, the triangles would be the number of sides minus 2, right? Which would equal 5. So that means the sum theorem, interior angle sum theorem, said we take the we take 180 times the number of the number of sides minus 2 to get the number of triangles. So we would do basically 180 times, and we said 7 minus 2, which is 5. So 180 minus 5 is 900. So we know that this would add up to give me 900 degrees. So go ahead and try this one. You try with a hexagon, and you can look back at your table. A hexagon has how many sides? You want to list how many sides do you have, how many triangles do you have, and you're basically taking that number and multiplying it by 180 to figure out your total. So pause the video, work on it. When you unpause, the answer is here. Oops, that is wrong. I was copying the previous one. Hexagon has 6 sides. That means 6 minus 2 is 4, so it has 4 triangles in there. 180 times 4 is 720 is what you should have gotten. Okay, find the measure of one interior angle of each polygon. So let me do this one here. So now we have a heptagon. So sometimes you're going to be given the actual shape. Sometimes you might be given the name. So what you need to do is make sure you know the names of the most common polygons, and that way you know how many sides each one has, right? Okay, so a heptagon has 7 sides. So the number of triangles it has is 5, because 7 minus 2 is 5. So we're going to take 180 times 5, and that's going to give me 900 degrees. Now that's the total, right? That's the total of all the angles in a heptagon. But I want to know only one interior angle. So if I want to know one of them, I would have to take this total and divide it by the number of sides. So the number of sides I have is 7, so that means each angle in that heptagon, in a regular one, would be 128.6 degrees. So go ahead and try that for the next one. Based on this number of sides, what would one interior angle be for that? So pause the video, see if you can figure it out, and when you unpause, your answer will be there. Okay, so you should have figured out that there were 9 sides here, which means there are 7 triangles. So 180 times 7 is 1260. But remember, we wanted one of these angles, not all 9 of them there. So what we're going to need to do is divide that number by 9, and you should get 140. Okay, we'll try a couple more here. It says this is a regular polygon. Given the information, find the measure of an exterior angle. So now we're doing exterior. And regular means that if one of them is 140, then all of them are going to be 140. They're all congruent there. All right, so if we're doing exterior, we're not doing interior, we're doing exterior. So I was just making sure you understood what regular meant there, okay? So if we're doing an exterior angle here, exterior means outside, right? If you look at this angle here, if I were to extend this out here, which you can, do you see how it forms a straight line there? Okay, so what can I do to figure out what this angle is, because that would be an exterior angle. And if this is 140, then this is 140. All of the exterior angles are going to actually be the same regardless of which one you chose, okay? So we would do 180 minus 140, because those would be supplementary, right? So that would give you 40 degrees. So one exterior angle would be 40 degrees. Now remember when we said all the angles would add up to 360? If you don't believe me, you can go ahead and prove it right now. So if this one is 40, then that means all of these outside angles, exterior angles, are going to be 40. How many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And 40 times 9 is 360. So I told you the truth. Okay, number 6. The measure of an interior angle, so make sure you're identifying, are they talking about interior inside or exterior outside? Of a regular polygon is 108. Find the number of sides here. So if a regular polygon has an angle, an interior angle of 108, so we're going to draw just a regular angle, label it 108. If we need to find the number of sides, what we can do is find the exterior angle first. And then after we find the exterior angle, we can take 360 divided by that in order to figure out the number of sides. So if you look previously, remember when I did that, I said, okay, if this is 40 degrees right here, I take that number times the number of sides, and that will give me 360. So I'm going to work backwards, right? So if I have the exterior angle times, this is the rule, the number of sides, and we'll just put n, right, because n stands for number of sides, equals 360, and I want to find the number of sides, and I would have to take whatever the exterior angle is, like you're solving, right? Solving for the missing variable here. And we would divide by that exterior angle from 360 in order to figure it out, right? N would equal 360 divided by exterior angle. So that's what we're doing here. So the exterior angle, we would take 180 minus 108. That's going to give me 72. So I would do 360 divided by 72, and that's going to give me the number of sides, which means you have 5 sides. So what is the name of this shape if the interior angle is 108? What is the name of this regular polygon? Well, if it has 5 sides, because we figured it out, a 5-sided polygon is called a pentagon. Okay, so let's see if you can try a couple of these. First, you're going to try one like this, find the exterior angle, and then you're going to use that theorem to go ahead and find how many sides it has. Okay, so here's your first one. Go ahead and pause the video And when you are done, check your answer. Okay, you should have gotten 12. 12. And a 12-sided polygon is called a dodecagon. Okay, so again, you're looking for the interior angle. I'm sorry, you're looking for the number of sides here. But you have the interior angle, so you know you can find the exterior one and take 360 divided by that exterior in order to tell you the number of sides there. All right, try this one now. Number 8, pause the video again and go ahead and try it. What is the measure of one exterior angle of a decagon? One exterior angle. So once we find the total angles, we're going to have to divide by the number of sides. So a decagon has how many sides? If you need to go back to your table, go back to your table and check. So pause the video, try it out. When you unpause, you will see the answer. Okay, so you should have gotten 36 degrees. So we said, remember, the total of all the exterior angles is 360. So you would take 360 divided by the number of sides to get the total angle. Okay, and that is pretty much it. So make sure you know how to get an exterior angle, how to get an interior angle. And you have to know the names of your polygons, how many sides each one has as well. That's it for today.